of information, but I want you guys to write it. So this table here is very important. Okay, so this is basically a flow chart that we're going to use to help us figure out how to get from mass to moles to atoms, or atoms to moles to mass. Okay, so I want you to fill in all these tiny little details. Okay, once you do that, you need to define Avogadro's number. Avogadro's number is 6.022 times 10 to the 23rd atoms, and that is equal to 1 mole. Please note that atoms are interchangeable with moles, particles, molecules, ions, pieces, parts, and so on. Okay? These problems require two-step conversions. Okay? So you're going to use 1 mole over the molar mass, or the molar mass over 1 mole, and 1 mole over Avogadro's number, or Avogadro's number over 1 mole. Okay, so go ahead and pause the video here so you can get all of this information down. So now that we've copied this top info down, we have 4 examples. Okay, so this first example, I'm going to go through it with you. So you should have your periodic table and your calculator ready to go. So again, when we're working on these types of problems, we always start with our given and our find. So given, find. Okay, so your given is always a number. So what number is given to us in this problem? And how many atoms are in 1.56 moles of silver oxide? So our given will be 1.56 mole of Ag2O. And we need to find how many atoms. So we're finding atoms of Ag2O. Okay, so this is a one-stepper. So there are multiple ways we can do this. So we are going from moles to atoms. Okay, so if you go from moles to atoms, we need to multiply by Avogadro's number. So this is how we're going to set this up. Okay, so you always start with what you're given. So I'm going to start with my 1.56 moles of Ag2O, dot and a line, equal sign. Mole of Ag2O will go on the bottom because I want it to cancel out. And atoms, Ag2O will go on top. Now remember, we're multiplying, you can't see that, we're multiplying by Avogadro's number. So we're going to come over to these 2 conversion factors. I've already set up my units, but if we're multiplying by Avo's number, we're going to use this conversion factor. And as you can see, these units line up, okay? So I'm going to plug in 1 for my moles, and where I have atoms, I'm going to write Avogadro's number, or 6.022 times 10 to the 23rd atoms. Oh, I'm so sorry. So this is my problem set up, ready to go. Okay, so now in my calculator, here we go. I'm going to write 1.56 parentheses 6.022 second button, comma, because it's the EE that I want. That will have an E pop up on my screen, 23. So notice my answer is now 9.39 E23. So when I write this answer out, it will actually be 9.39 times 10 to the 23rd atoms of silver oxide. Okay? So my answer is 9.39 times 10 to the 23rd atoms of silver oxide. And I'll put a box around that. So we know where your answer is. So that's how we do the first problem. Let's look at the second problem. So for example 2, how many moles of silver are in 3.52 times 10 to the 26 atoms? Okay, so now we're going from atoms to moles, okay? So first things first, let me set this up so we all can see this. We are going to start with our given, okay? Now what's given to us is a number. So our given is 3.52 times 10 to the 26. And the unit on that is atoms of Ag. And what we're trying to find is how many moles of silver. So find mole Ag. Okay? So, again, we're starting in atoms and we're trying to go to moles. So if we look back up here at this flow chart, we're starting in atoms and we want to end up at moles. So this means we're going to divide by Avogadro's number to get to moles, okay? So looking at our conversion factors, this doesn't have Avogadro's number, so we're ignoring it. We're working with these two. If we're dividing by Avogadro's number, we're going to use this conversion factor, okay? So let's set up our problem. Again, remember to always start with what you're given. So I'm going to start with my 3.52 times 10 to the 26 atoms of silver, a dot and a line. So my atoms of silver will be on the bottom because I want them to cancel out. And remember that Avogadro's number always goes with atoms. So I'm going to go ahead and plug in 6.022 times 10 to the 23rd. And I'm going to put 1 mole of silver over that. Okay. Remember, from the flow chart at the top, we know that we are going from atoms to moles and we need to divide our given by Avogadro's number. So let's do it. In your calculator, and I'll go on this side, there's a glare. So in our calculator, we're going to type a parenthesis, then 3.52, second button, comma, to get the E, 26, close parentheses, divided by parentheses, 6.022, second button, comma, 23. Close parentheses. And as you can see, we get an answer of 584.52. Okay, so that's what my answer will be, and that's what I'm going to write here. So we have a total of 584.52 moles of silver. Okay, so that's example 2. Let's move on to example 3. So, for example 3, the question is how many atoms are in 0.725 grams of carbon? So, what is given to us in this problem? Notice, you can start these problems at any point. You can start by looking at the flow chart. You can start by setting up given or find. It doesn't matter. So given, we have 0.725 grams of carbon. And we're trying to find how many atoms. So find atoms of carbon. So now I'm going to consult my handy dandy flowchart up here, okay? And that is awful. All right, so we're going from mass and we need to get all the way to atoms. So this is a 2-stepper. Here we go. We're going from mass. So we need to divide by the molar mass to get to moles and then multiply by Avogadro's number to get to atoms. Let's see it in practice. This means we're using 2 conversion factors here. So Dividing by molar mass, we're going to choose this one. Multiplying by Avogadro's number, we're going to choose this one. So here we go. Let the units guide you, okay? So remember to always, always, always start with what you're given. So we were given 0.725 grams of carbon, dot and a line. Grams of carbon needs to go on the bottom because I want that to go away. So when we have grams of carbon on the bottom, we know that we're dividing by the molar mass, so we know that a mole of carbon needs to go on the top. So for right now, what number always goes with mole? Check your conversion factors. That would be a 1. The grams of carbon, since we're given a pure element, we need to plug in the atomic mass. The atomic mass of carbon from your periodic table is 12.01. If this was a compound, we would need to calculate the molar mass, but we got an easy one today. So we need to find atoms. We're ending in moles, so we're not done, meaning we need to do a dot and a line. Mole of carbon needs to be on the bottom because I need that to cancel itself out. And atoms of carbon will be on the top because that's what I want to end up in. So, looking back up here at our conversion factors, moles on the bottom, atoms on the top. That doesn't match? Hey, but this one does, so we'll use that one. So I'm going to plug in 1 for my mole and 6.022 times 10 to the 23rd for my atoms. So it's set up. All we need to do is calculate now. So here we go. Let's see. And you can see the calculator perfect. How we'll do this, everything on the top gets multiplied, everything on the bottom gets multiplied, then we divide. So we have 0.725 times parenthesis 6.022 second E 23. Close parenthesis. And you get that number. Now 12.01 times 1 is itself. So I'm going to take this number, divide it by 12. And I get 3.64 times 10 to the 22nd atoms of carbon. Okay, so as a rule of thumb, whenever you're calculating atoms, you're most likely every single time going to have a E number. Okay, so for this one, we have 3.64 times 10 to the 22nd atoms of carbon, and our work is done. Okay, so you're most likely, when we're calculating atoms, you're going to have a times 10 to a number. Okay, there's atoms, there's a lot of them, and they're really small. Our last problem, how many grams are in 4.83 times 10 to the 27th atoms of sodium chloride? Okay, so again, I'm going to start with my given and find because it just makes my life a lot easier. So given to me is this many atoms. So 4.83 times 10 to the 27th atoms of NaCl. And we're trying to find grams of NaCl. So again, we got another two-stepper. Okay, let's see. Let's consult our chart. So again, and I don't know how to make this good enough. So we're going from atoms this time all the way to mass. So it's a two-stepper because the first thing we're going to have to do is divide by Avogadro's number to get to moles and then multiply by the molar mass to get to grams. So here we go. Okay, so remember to always, always, always start with what you're given. So I'm going to start with my 4.83 times 10 to the 27th atoms, NaCl, dot and a line. Remember, I'm going to need atoms of NaCl on the bottom, so they cancel each other out and they go away. And, I'm going to have atoms on the bottom, so I'm going to have mole on top. We always go through the mole to get from atoms to grams. 1 is the number that always goes with mole. 6.022 times 10 to the 23rd is the number that goes with atoms. So we're trying to find grams, and we're at moles. So we're not done. That means we need a dot and a line. A mole of NaCl on the bottom, so it cancels itself out and goes away. Grams NaCl on the top, because that is what we want. 1 is the lucky number to go with mole. Grams of NaCl. This is where we need to calculate the molar mass. So the atomic mass of sodium is 22.99, and the atomic mass of chlorine is 35.45. Add those two together, and we get 58.44 grams per mole. There's where our unit comes from. So we are ready to do some calculations. Here we go. You can see my calculator. Again, everything on the top gets multiplied, everything on the bottom gets multiplied, then you divide those two numbers. So we have parenthesis, 4.83 second, 27, close your parentheses, times 58.44, and you get that number. You're going to divide, because anything times 1 is itself, so we save a step right there. You're going to divide that by parentheses, 6.022 second, 23, close parentheses. And we get a really big number. That makes sense. We started with a ton of atoms. A ton. 23 and 27, that's 4 powers, okay? That's a ton of atoms. This makes sense. So I'm going to write, and I'll switch sides. My answer is 4, 6, 8, 7, 2, 3.35 grams of NaCl. Okay, and I'm going to put a box around that. It's a weird box because I ran out of space, but that's okay. We just improvise. And there you have it. That is our problem completely done. So I hope this clarifies converting from mass to moles to atoms. My big takeaway here is, remember, this flowchart is your best friend. You always have to go through the mole. For now, the mole will always have 1 in front of it. Okay, so make sure you get this chart down. This will save you a bunch of time. All right, good luck.